Welcome students. Last class we have learned about to find the number of images when two mirrors are at an angle, correct? Maybe for odd or even we have found it that one I told you to find out, and some homework also I have given you. Today we'll go for a new topics. If your mirror changes for a particular angle, though the source is same, what will happen to the reflected ray? Or you can see here, just imagine this is your mirror, there is a source, then this is a reflected ray, this is incident ray, reflected ray, so R, and this is the normal, M, P. Clear? So according to the reflection law of reflection, we know that if this is angle of incidence and this one is angle of reflection, and we know I equal to R. Now the question is, if your mirror if change or it turns by an angle theta, now it is your new position of your mirror, by an angle theta, that is M dash P dash, what will happen to the reflected ray, though the source is in same condition. Now if your mirror also changes, your normal also will change by an angle theta. Now that is your new normal N dash. Clear? So now the source is in same condition, mirror it changes by an angle, so what will happen now? That reflected ray also will change R dash. So they are also theta, so this one also will change. Now we are going to find the difference, that how much the reflected ray it change if the mirror changes by an angle theta. Clear? So now let's see here. In the first case when the mirror is MP, in that case what is your angle S? If you consider this one is O, S O N is R. Same to same angle N O R also. This one is I, this one is R. And we know I equal to R. This means these both the angles are same. Now, if your mirror is reflected by an angle theta, now what is your angle of incidence? This is your angle of incidence, this is your angle of reflection in the first case. In new case, after it rotates by an angle theta, that means M dash is theta. In that case, your angle of incidence that is angle S O N dash will be S O N dash will be I plus how much? I plus theta. Same to same, your angle of reflection, that means angle, which one? Angle of reflection will be N dash O R dash will be R plus theta. Now let's find the change in angle. So if you want to find the change in angle, the change in angle, that will be angle S O R dash minus angle, so yes, S O R. So for the angle of S O R dash, you can find out from here I plus theta plus R plus theta minus I plus R. If you open the bracket and cancel these terms, your answer will be 2 theta. That means if your mirror rotates by an angle theta, your incidence ray, the reflected ray will rotate by an angle 2 theta, that is double of the mirror rotation. Clear? Okay. So this is one of the topic of plane mirror. We are going to finish our plane mirror one. Then another topic is, you know already, that is, what is there? Your left hand will become right hand, that is inversion, lateral inversion is there, correct? When you go in front of mirror, your left hand will become right hand in the image. Clear? I am not going to that topic, that is very easy one, you have already studied in smaller classes. Next one I am going to study the velocity. The velocity, how the velocity will change. How the velocity will change when your object will change. Velocity of object and image. Now, if it is a mirror, now the mirror is rest condition, mirror is not moving, only the object will move. For example, one object from the mirror, it is moving in this direction x. So what will happen there? Your object, this image also will move backward direction by y. So they are moving opposite direction. They are moving in opposite direction. Now if you want to find the rate of change with respect to the mirror, rate of change, you can find out x equal to minus y. Why it is minus y? Because they are moving in opposite direction. Now if you want to find the rate of change, that is dx by dt will become minus dy by dt. And you know what is dx by dt rate of change is called as velocity. That means this one is object, this one is image. That means velocity of object is equal to minus velocity of image. In this condition, the mirror is in rest condition, correct? Mirror is not moving. Now what will happen in that time? Your object also moving and mirror also moving. Its object also moving and mirror also moving. That time what will write here? There we will write V object minus V mirror, that is velocity of object minus velocity of mirror, equal to minus of velocity of image minus velocity of mirror. Now if you open the bracket, it will become VO minus VM is equal to minus VI plus VM, VO plus VI equal to 2VM. So Vm equal to VO plus VI by 2. There is a relation between what is there. V is the velocity of mirror, O is the velocity of object, and I is the velocity of image. Using this formula, there is some relative questions will come. You have to learn. Clear? Then some are there uses of plane mirror. That one you can study from the book. I am not going to deal with that one. Now, after plane mirror, let's go for spherical mirror. New topics we are going to enter, that is called spherical mirror. What is going to happen there? We are going to discuss. Clear? Spherical mirror. Spherical mirror. Yes, that is important topics you have learned in small classes also, before also class 9, class 10. Now let's see little bit. Now there is two types of spherical mirror. One is called concave mirror, one is convex mirror. But imagine one sphere. Imagine one sphere. Clear? Now if you cut a sphere in this way, don't imagine like a circle, just imagine like a sphere, like a ball. If you cut a circle and you that bulgy side you coat it, and here also you cut, and this depressed side you coat it. So this portion also behave like a mirror. This portion also behave like a mirror. This one is called as what? Concave mirror, and this one is called as convex mirror, this one. Clear? Now they are also part of a sphere. That sphere also having a center. This center is called as center of curvature, that is called the center of curvature. And this portion here to here, this curve we used to call as aperture. Clear? So the distance from the center at the center of this aperture, this distance is called as radius of curvature. This is called, so as it is a part of a sphere, the center is called the center of curvature. This curved portion which you have coated or behave like a mirror, we call it as a aperture. Then the radius that means from the center and the aperture, that is called as radius of curvature, that I told already, that is called radius of curvature. Now another thing is the center of your aperture is also called as pole. Okay, clear? This is called pole. Now if it is a convex mirror, this is the center of curvature and this is a pole. The axis which join the poles and the center of curvature is called as principal principal axis. So these are the technical terms we need to know for spherical mirror, as I told, correct? If your multi size is coated, that is called as concave mirror. If your depressed side is coated, that is called convex mirror. You already know these terms. What is center of curvature, what is aperture, what is pole, what is radius of curvature, correct? What is principal axis, you already knows about this, correct? Now we are going to study for the ray diagram. Or another term is there, that is called focus or focal point. What do you mean the focal point? Clear? Focal point. It is called focal point. Now this is your concave mirror and this one is your convex mirror. Let's see what will happen. This is center of curvature. This is center of curvature. Now what will happen? The ray of or beam of light or ray of light, they passing as a which are parallel to the principal focus. Okay, the principal focus. So as you know the center of curvature, that means this is perpendicular to the aperture, also perpendicular to the aperture. So they will reflect back at the same angle and both the ray of light will meet at a point. Correct? Actually they will meet at a point. That point is called as focal point. Clear? Same to same here also. If ray of light, they come parallel to the principal axis. Now this is perpendicular. So what will happen? This one is the angle. So at an angle, they will reflect back. Here what will happen? It will look like they are coming out. There appears to be mid. That means they are coming out. They are coming out from a point. That point is called as focal point. So that is here the focal point is real and there it is virtual. There is virtual exists. So by dotted line we have drawn. Now remember the line, whatever parallel we are talking, that line should be close enough to the principal axis. That is called as para-axial line. Para-axial line. This line, it doesn't mention in the book because in the book they consider that this aperture is very small. Correct. So they should be close enough to the principal axis, that is called as para-axial line. In that case only they will meet at a point that is called focus. But if they are far away from the line, that is called as which one? That is called far away from which one? This principal axis. Those lines sometimes they will not meet in focus. Clear? So remember in our study the aperture of this one curved mirror or spherical mirrors is too small, so that the line after that reflection they will meet at a point that is called as focal point or focal. There it appears to come out from a point that is called focal point. Correct? These are the technical terms we have learned. Okay. So now let's see what is the relation between, which one? Relation between focal length and the radius of curvature. Our next topic is the relation between focal length and the radius of curvature. Relation between R and F. Clear? In small class we have studied this one also. What is the relation between? So both way I will show you, easy one, another one is in class 12 start. So this is a mirror. One line is coming parallel to principal axis. This is center of curvature C. After the reflection, they will meet at a point. This point is F. So the distance is called as sun, and this one is called as radius of curvature R. What is the relation between that? We are going to find. This one is optical center O. Let's consider this one is P. This I. Now, according to the law of reflection, what do you know? This one angle is angle of incidence, and this angle is angle of reflection. As these two lines are parallel to each other, this one I mean this one also I. Clear? We know this is I also, this one also I. Now, as you can see, in this triangle CFP, in this triangle, angle PCF equal to angle CPF, that is angle of incidence, angle of reflection. That means if these two angles also same, that means the opposite side or corresponding side to that angle also same. That means PF equal to CF. Okay, PF equal to CF. As I told, the aperture is too small. As aperture is too small, that means OP is too small. This OP is too small. In that case, we can consider that PF equal to OF. PF equal to OF. That means F is PF equal to OF. That means F is midpoint of OC. That means if this one is X, this one also X. As the aperture is too small, this one also X. That means F is the midpoint of O and C. That means R equal to 2F or F equal to R by 2. That's the relation you have learned in smaller classes. Clear? Now, let's see, as you are in higher classes, we cannot write in that way, we will see some other method also. Clear? Now, let's see in other method. As already told, this one is I, this one is R, I equal to R. So these two sides are already same, and this one is, if this one is radius of curvature, this one also radius of curvature. Now from here, as it is an isosceles triangle, which is two sides are same, if you draw one perpendicular here, if you draw one perpendicular, this portion will be R by 2. Let's see, this portion also will be R by 2, right, light here M. Now in your triangle M, this portion is F, this one is C, this one is I, this one is R by 2, this one is 90 degree. Now what is the relation between that? If we want to find this portion, this is perpendicular, this is base. Now what is cos theta? We have learned cos theta, or you can write cos I, or letter like this one is theta. This one also will be theta. This one also consider theta. So what is cos theta from here? Cos theta is base by hypotenuse. That means base which one? CF by hypotenuse. Which one is your hypotenuse? Sorry, CF by hypotenuse. Which one is your hypotenuse? This one is CF is your hypotenuse. And which is your base? R by 2 is your base. From here, what is your CF? You can find out from here your CF is R by 2 cos theta. Now 1 by cos theta we can write R by 2 sec theta. Clear? That means this portion is sec theta and this is your F. Now from here, what is your F? If you want to find the value of F, your F will be total distance is R minus R by 2 sec theta. This is the real value of real relation between F and R. Now what we mentioned that this aperture is too small. If the aperture become too small, this angle theta, if aperture is too small, then theta also too small. If theta become too small, so what is the value of cos 0? 1. Sec 0 also 1, we know. This is theta becomes 0, almost to 0 only. That means sec theta value we can write 1. In place of sec theta, the value becomes 1. That means if this portion becomes 1, we will get F equal to R minus R by 2. So R minus R by 2, the value also become R by 2, which on the previous relation you have learned in smaller classes. So this derivation is higher for the higher classes because your actual value this one, correct? But if the aperture is not too much small, the value will change according to the angle of theta. As we mentioned here, the aperture is too small, theta also small, the value becomes 1, so that we will get the relation between them in this way. Clear? Now see, now we will know how to draw, or the properties or the formulas or the steps how to draw diagram, ray diagram for mirror. So first let's see for the concave mirror. Let's see for the concave mirror how to draw ray diagram. There is a condition how to draw the ray diagram. So first one is your mirror, this is center. So one first ray, if coming parallel to the principal axis, after the reflection they will go through the focal point. Clear? So second one is this is your center. Now if the ray it goes through focal point, after reflection it will become parallel. This is the first. So first one is if it goes parallel, after reflection it will go through the focal point. There if it go through the focal point, after the reflection it will become parallel to principal axis. Next one is what will happen if it fall, if the ray light it fall on directly in optical center. The angle at which it will fall, again it will reflect back in same way. Clear? At last one is if the light ray goes through principal axis, again you will reflect back. The way it will go, again it will reflect back. So these are the 4 ray diagram. Using this or any tool, these two maximally we are going to use to complete our ray diagram. Clear? So you have studied about the which one? Focal point also you have studied. The ray diagram procedure, how the steps by step will make. Now let's see what is the focal plane. Another topic is there that I forgot to tell you there. What is the focal plane? That means focal plane. Let's see the focal plane. It is called focal plane. Focal plane is nothing but that we saw that if the light ray comes parallel, they meet at a point, there is focal point. But what will happen if it doesn't comes parallel to? For example, if ray of light If that doesn't come parallel to, they comes in this way. What will happen? So this is your focal. Now it will become parallel. Now again it meet here. So they will not meet at focal point. In that focal point, you can imagine one plane. On this plane, they might meet. On this plane, they might meet. That plane is called as focal plane. Clear? It's I'm showing for concave mirror. When the ray of light they are coming parallelly. After that, they will meet at a point. Okay, they come parallelly. They will meet at a point, one point. That point will be in the focal plane. On this focal plane. Clear? That might not be exactly the focal point at the principal axis. On this plane, somewhere they will meet. Clear? So that plane is called as focal plane. You can draw for convex mirror also. Clear? So today what we have learned? We have learned about plane mirror. If you rotate at an angle, how your plane mirror is to our incidence or reflected rays to reflect. Correct? Then about the velocity, about curved mirror or spherical mirror, then their property, how they have shown you what is the technical terms. Clear? Then the steps for ray diagram, what are the main 4 ray diagram, then using based on this 4 ray diagram we are going to apply it later on. Now I have shown you about the focal plane. Clear? So these are the things you have to practice in home by doing ray diagram. Clear? So now next classes I will tell you how to draw the ray diagram. Clear? Ray diagram means in different position we are going to fix our image, object. Corresponding to the position of the object, we will see how the image is to behave. Correct? And the property of the image, how is to find. Thank you.